Electronics is the backbone of modern civilization. Every computer, every smartphone, every satellite, and even medical equipment rely on tiny electronic components. But all of this advanced technology begins with a single concept: semiconductors. In nature, materials can be divided into three groups: conductors, like copper, that allow electricity to flow freely; insulators, like rubber or glass, that block electricity; and in between, semiconductors, which can behave like both depending on how we treat them. This ability to switch between conducting and insulating states makes semiconductors unique and powerful. The most common semiconductor is silicon. Pure silicon forms a crystal structure, but in its natural state it is not very efficient at conducting electricity. That is why engineers modify it using a process called doping. Doping means adding tiny amounts of other elements into the silicon crystal. When we add elements with extra electrons, we create N-type silicon. When we add elements missing electrons, we create P-type silicon. This process allows us to control the flow of electrons, and it transforms silicon into the foundation of the electronic age. When P-type and N-type semiconductors are joined together, something incredible happens. At the boundary, electrons and holes combine, creating a thin region called the depletion layer. This junction acts as a gate for electricity. Under certain conditions, it allows current to pass. Under others, it blocks it. This is the birth of the diode. A diode is one of the simplest yet most important devices in electronics. It acts like a one-way street. Current can move forward, but it cannot go back. This basic function makes it essential for countless circuits. One of the most common uses of diodes is rectification. In power supplies, diodes convert alternating current, or AC, into direct current, or DC. Without rectifiers, your laptop charger, your phone adapter, and nearly every electronic device would not function. Diodes are also guardians of circuits. Zener diodes regulate voltage, preventing damage from power surges. Other diodes protect sensitive components by clamping dangerous spikes. Another fascinating type of diode is the LED, or light-emitting diode. When current flows through it, electrons release energy as light. LEDs have revolutionized lighting, displays, and indicators, combining efficiency with durability. In communication systems, diodes are used in radio receivers and signal processing. They can detect, switch, and control signals at very high speeds, enabling modern wireless technology. Without diodes, the electronic world as we know it would not exist. They are not just simple components, they are the foundation for power conversion, communication, lighting, and safety in circuits. The diode is only the beginning. By combining millions and later billions of semiconductor junctions, engineers created transistors, integrated circuits, and microprocessors. From the simple PN junction grew the digital universe: computers, smartphones, and artificial intelligence. The story of electronics starts with semiconductors and the invention of the diode. It is a story of science, engineering, and human creativity. Every time you turn on a device, you are witnessing the invisible power of semiconductors at work.